All right, hey there, guys. My name is Wilfred. I'm a senior math tutor, and today I'll be covering 11 questions based on algebra. And a little backstory upon myself: I graduated from a master with a major in biochemistry and a minor in mathematics. And if you have any other issues or problems with your questions, please submit them to OneClass, and we'll get to them as soon as possible. Other than that, let's begin. Okay, so the first question reads, what is the square root of 50 in the simplified radical form? So before we even begin to tackle this question, there's a few properties of square roots, the square root function that we can use to help find us the simplified radical form. Okay, so the first property that we're going to use is this. So if we have the square root of, let's say, a times um, a times b, we can write this as the product of the square root of a times the square root of b. Okay, so that's what we're going to use to help us find the simplified radical form. So the technique that I like to use and I like to utilize for this is to find the prime factorization of 50. And what I mean by the prime factorization is to break up 50 into prime factors. And prime factors are basically factors that are prime numbers, and prime numbers are basically numbers that can only be divided by 1 and itself. Okay? So let's look at 50 and let's try to find the factors of 50, okay? So 50 has a lot of different factors. We have 2 and 25, for example, right? 2 times 25 equals 50. We can have 5 and 10, right? So we're going to use either one is fine. So we're going to use 2 and 25, right? So we see here that 2 is one of the prime factors of 50 because it's a prime number, but 25 is not. So we can further break this down. So you can further break down 25 as 5 times 5, right? So now we see here that the prime factorization of 50 is going to be 2 times 5 times 5. All right. If we were to do the other pairing, for example, 5 times 10, we see that 5 is a prime factor, but 10 is not. So we can further break down 10 into its prime factors, and it's going to be 2 times 5. And we can see here that the prime factorization is always going to be the same for any number. So our prime factorization here is 2 times 5 times 5. So how does that help us with the square root of 50? So first of all, the square root of 50 can be written as, sorry, just give me a moment as I adjust my writing pad. So the square root of 50 can be written as the square root of its prime factorization. Okay, sorry. Which is 2 times 5 times 5, right? So we already know that 2 times 5 times 5 is equal to 50, right? We can alternatively write 2 times 5 times 5 as 2 times 5 squared. Okay, so we just took these two 5's together, and 5 times 5 is also equal to 5 squared. Finally, we're going to apply our property of the square roots, and we're going to break up this square root bracket. So we're going to have the square root of 5 squared times the square root of 2. So we see here that the square root of a squared number is just the number itself, and that is going to equal this. And the square root of 2 is not a perfect square, so we're just going to leave it as the square root of 2. And this is the simplified radical form of root of 50. And we see here that we got there by finding the prime factorization of 50 and then breaking it down so that it's in its most simplified form. We see here that we're square rooting a prime number and it doesn't have a perfect square at all. We can approximate it by using a calculator, but we're going to leave it as such. So this is what we call the simplified radical form. It consists of a whole number times times a square root of a number that is not a perfect square. So other than that, this answer is correct, and we can move on. All right. So the next question reads,